Good morning, ladies and gentlemen. I welcome you all to this very important event, which is related to the anthropogenic emissions in the land sector. On podium, I would like to welcome, we have Professor Jimsky, the IPCC chair. We have Yohong from UNFCCC. We have Giacomo Grassi from GRC Sprightly. Ladies and gentlemen, I would like to contextualize this event by mentioning that climate modelers and IPCC inventories experts use different methods to estimate the land sector emissions, and there are certain differences. And under the UNFCCC Paris Agreement, the differences are of importance. And with this context, in January, at the IPCC's 60th panel, it was decided that All the relevant experts will sit together in an expert meeting to come up with a discussion and start a constructive dialogue in this regard about the differences of emissions. Accordingly, in July, an expert meeting was held, and about 111 experts from different expertise like Earth observation, modeling, and GHG inventory specialists sat together and they discussed about the differences. Today's session is all about the outcomes of that expert meeting, and we are also going to present these findings to the upcoming IPCC's scoping meeting that is scheduled for next month. With this, I would like to invite Professor Jimsky for his remarks.
Okay, thank you very, very much, Mazar. Now, just to start by saying, Italians have made many contributions to mathematics and science. Think of the Bernoulli theorem, the Fibonacci sequence. And now there is something in IPCC known as the Grassi issue. My colleague Giacomo Grassi at the end has given its name to this apparent discrepancy between emissions from land as estimated by global bookkeeping models and the inventory systems. And, Giacomo has been assiduous in drawing our attention to this very significant discrepancy because it is not small. I think it's around 5 gigatons, that kind of order of magnitude at the moment, close to 10% of global emissions. So this is very significant. And the reason that it matters is that many of the net zero timing numbers that have come from Working Group 3, especially of IPCC, are based on the global bookkeeping method. And if you were to reprocess the numbers on the basis of the inventory methodologies, the timing of net zero would be different. And we have to acknowledge that. The other thing would be different as to which countries are negative emitters and which are not. It could change the classification depending on the methodology that's used. And I think what is really important to note, this is not a problem of uncertainty in science. It's a question of the way that emissions and sinks are framed and the way that it implicitly implies the difference between anthropogenic and natural emissions. So I have been very enthusiastic and encouraged Giacomo to persist, though he doesn't need any encouragement to persist, I should say that. I was enthusiastic about it. I was enthusiastic about the expert meeting that took place in Ispra earlier this year, though unfortunately I wasn't able to attend. So I'm going to stop here. Having put my enthusiasm and my support behind this initiative. I think the important thing is to get to the detail, get to the findings of the expert meeting, and move onwards. And at that point, Mazar, I'll halt my remarks.
Yeah. Thank you very much, Jim. Now I would like to invite Ms. Shuai Ong from UNFCCC. Thank you.
Thank you. I hope you can hear me. Good morning, dear colleagues. It's really a great pleasure to see so many familiar faces here and so many distinguished and experts in this field. This is a very important event. So thank you very much on behalf of the UNFCCC Secretariat and the Transparency Division for inviting us to this event and share our perspectives. I would like to share our perspectives mainly from the transparency process under the UNFCCC and going forward under the Paris Agreement, and how this event is relevant to our work in the implementing the enhanced transparency framework going forward, and of course to inform policy decisions under the multilateral process. So 2024, this year is a very important year for our for the transparency process. As you may know, the first biannual transparency reports will be submitted by all parties under the Paris Agreement by the end of this year. And then in this biannual transparency reports, of course, parties demonstrate their progress in implementing NDCs, implementing the Paris Agreement. And national GHG inventory information is really the underpinning information that informs this tracking progress. Land use and forest LULUCF sector is a key component, as we all know, of the national GHG inventories. And many parties have actually incorporated their land use activities in their NDCs. So strong scientific knowledge of land processes, as well as quantification and mitigation options, is essential for enhancing transparency and addressing climate change, both for the IPCC and for parties. So additionally, I would like to say a few words on REDD+, given the relevance. REDD+, as many of us know, is reducing emissions from deforestation and forest degradation in developing countries. It remains an important focus for mitigation actions in the forest sector in developing countries. Further, the global stocktake recognizes REDD+ as a central tool to halt and reverse deforestation and forest degradation by 2030. So in response, as you may know, the GCF board adopted a policy on REDD+ results-based finance just last month, and which builds upon the UNFCCC transparency process, the REDD+ processes. So given the importance of data submitted by parties on anthropogenic emissions and removals, along with the rigorous technical review process that will soon follow after the submission of BTRs. So it is essential for all actors, including inventory compilers, reporting to the UNFCCC, IPCC climate modelers, and Earth observation community, to work towards a shared understanding of aggregated anthropogenic fluxes from land use. So this includes gaining insights into each other's environments, terminology, and reporting and legal requirements, such as the UNFCCC's mandatory reporting rules. Reviewers also need to be aware of these factors when assessing parties' submissions. The alignment of findings from the IPCC 7th assessment cycle, the reporting and review process under the of the first BTRs, and the corresponding inputs to the second global stocktake presents a crucial opportunities to carefully consider these issues. So I would say on behalf of the Secretariat, we look forward to continued collaboration and exchanges of views with the IPCC and to follow your work very closely, as we know that IPCC also keeps a close eye on the UNFCCC activities. So with that, thank you very much again for inviting us.
Thank you, Sean. Now I would like to invite Grassi for his presentation. If easy, you can come here.
Good morning, everybody. Can you hear me? Okay. I don't need that. Okay. Good morning, everybody. I would start providing an overview of the report that has been held last July, attended by more than 100 experts, as Mazar explained, from different communities. You can download the report and see all the presentation and 38 posters made by countries in this QR code. I'll leave you a few seconds for you to... Okay. So to start with, this is the global carbon budget. I guess several of you are familiar with that. On the left side, the left two boxes indicate the anthropogenic fluxes, mainly fossil fuel, and then anthropogenic land use emission. Half of these fluxes remain in atmosphere. Luckily for us, the other half is absorbed by natural sink, half terrestrial and the other half ocean sink. What is the problem we are discussing here? Is that the global models consider anthropogenic the an emission of 4 gigatons of CO2, the second box. While according to the national greenhouse gas inventory definition that follow the IPCC guidance, the LULUCF, the land use anthropogenic emission, has a different system boundary that is indicated by the dashed orange box. So is a matter of different definition, different system boundaries. So while if you open the IPCC assessment report and look for the emission from the land sector, you found an emission of about 4 billion tons of CO2. If you sum up all the country inventory, you find at global level a sink of about 3 billion tons. The gap is a gap of 7 gigatons of CO2, which is equivalent to 15% of all greenhouse gas emission, is essentially a labeling issue. The climate modeling community call it natural, while the national inventory call it anthropogenic. The topic is, the problem is that inventories follow the managed land proxy and apply a broader definition of anthropogenic sink. We can come back later with a panel on the details of what managed land means. But in a snapshot is that inventory consider a greater area of managed land than models, and on this area, the fraction of the land sink that is caused by the so-called indirect human-induced environmental change, including but mainly, but not only CO2 fertilization effect, which enhance tree growth, is treated as anthropogenic by most national inventory, while it's called natural by climate model. So it's mostly an issue of different definition, different labeling of the same fluxes. Is this mismatch in definition a problem? Well, to understand better, let's use this analogy. Let's put the Paris Agreement into a car. Imagine the driver is the policymaker, hold the steering wheel, decide the speed and direction. Then you have the car dashboard that provide essential information to the driver, like the national inventories. And then you have the model that is, they provide essential information, allow the driver to select a destination and provide possible route, like the GPS. The same exercise is done in the global stocktake. The global stocktake, like the driver, can compare the information from the car dashboard with the navigation system. The global stocktake does the same. So the global stocktake assess the collective progress of where we are based on national inventory NDC compared to where we should be based on the modeling. Thank you, Jim. Thank you. What is the problem there? Is that actually the driver finds himself in this funny situation that a car dashboard has kilometers as a metric, while the models use miles. So this lets you understand there is no one right and one wrong. People often ask, okay, who is right, who is wrong? No, there is no one right or wrong. The only mistake we should avoid is compare one against the other. This would be an apple to orange comparison. And this is why in the global stocktake, essentially the land use data from country has been ignored because of this mismatch in definition, mismatch in numbers. So the problem, the confusion arrive like a driver has different metrics and get confused on the direction and speed. So it is a problem to understand where we are, first problem. Another problem is that the importance of land use fluxes, as you know, of LULUCF, will only increase with time. These are representative pathway of emission reduction consistent with 1.5. And you see that emission from fossil fuel are expected to decrease, but not all emission can be brought to zero. Some residual hard to abate emission will have to be offset, compensated by an equivalent amount of CO2 removal. And the main tool we have now to remove CO2 from the atmosphere is through forest. And according to the IPCC Working Group 3, 20-30% of global mitigation for Paris Agreement compliant scenario comes from CO2 AFOLU. This is also reflected in countries NDC. According to country NDC, 20% of net mitigation effort are within LULUCF. Despite that, because of the confusion we have seen in the previous slide, the country LULUCF information has been essentially ignored from the assessment of collective progress in the global stocktake. If you open the global stocktake, the country LULUCF information for the historical period and the NDC has been missing. We can't afford this at the next global stocktake. That's why we held this IPCC expert meeting in July. We gathered all the main community involved in that. Essentially, on the one side, the global carbon modeling community supporting the IPCC assessment report, including the global carbon budget, the integrated assessment models. On the other side of the spectrum, we have in red the national inventory community that support the implementation of the Paris Agreement. Somehow in the middle, the yellow box is the Earth observation community that provide key information to both of this community. The objective of the expert meeting was to, following the Talanoa structure, was to understand where we are, where we want to go, and how we get there. In practice, to develop a common understanding of the gap in land use estimates between the communities, between the IPCC assessment report and the mitigation process under the Paris Agreement, set the basis of greater collaboration between communities, and outline concrete steps that each community can take to ensure greater comparability between future IPCC products and national greenhouse inventory data. The ultimate challenge is to achieve more credible and comparable LULUCF estimates, allowing the next IPCC assessment report and the next global stocktake in 4 years from now to assess the role of land use with more accuracy and consistency. So where are we? To set the scene, we started with a Slido poll in the expert meeting. We don't do it here, but the first question was, we had the best expert in the field, the best expert from the global carbon modeling community, from Earth observation, and from national inventory. And then we asked a question that even a friend or your mom can ask you. Okay, you are expert on global carbon budget. Have global emission from deforestation increased or decreased in the last 20 years? So raise the hand. Have emission, in your view, increased? Raise the hand if you think that the emission from deforestation is increasing. Is it increasing? Raise the hand. Okay. Is increasing. Who think that is actually decreasing? Okay. Well, then the expert present at ISPRA replied half and half. So when you ask the expert, well, sometimes the expert depends who you ask. A similar question is land use, anthropogenic land use, a sink or a source? Again, very diverse answer. So in practice, what we had here is we had two communities that have been working on the same topic for the last 20 years, but for a number of reasons we may discuss, didn't communicate each other much. And so this was the first step to start this dialogue. So we are now in this situation. We have two communities, the climate science community and the national inventory community, which is still, anyway, based on science, that we are in a phase in which we are somehow blaming each other. So the scientific community say, well, national inventory, why don't you follow my approach? And then the other, why don't you follow my approach? And then the climate science says, well, but including the natural sink in your accounts, you are overestimating your climate progress. And your net zero won't be enough to stabilize temperature. But then the national inventory teams, the policymakers say, well, look, I'm following the IPCC guidance, UNFCCC rules, so I'm doing my job. And actually what the call that you call natural is indirect human induced and exists because I protect that. And then the scientific community say, well, you should follow my approach. And then say, no, sorry, with my measurement, with my direct observation, which is the basics of my policy, I cannot follow your approach, full stop. So this is the starting point of the debate, which was not an easy one. Many of you were there, so you can witness the interest in the dialogue, but also the mutual skepticism. So each community look at the other saying, well, I'm right and you are wrong. Well, we started a dialogue and will be a long route, will not be necessarily an easy one. So the idea is that we speak different languages. We use this analogy of the languages because there is no one language better than the other, but clearly we need a translation to ensure the dialogue. So we agree on the translation. The translation is needed, but which is the direction of the translation? So at the IPCC meeting, it was clarified that the flexibility is not the same in the two communities. For a number of reasons, national inventories are not very flexible. They used direct observation that do not allow separating the direct and inter-anthropogenic fluxes in the same way global models do. On the other side, global models are more flexible, and their result can be disaggregated in a way to make them more conceptually comparable to national inventories. Also to make new model runs to make this model more comparable. At the same time, it is crucial that both the original models result and the translated version are available in the future IPCC assessment report and global stocktake. This would enable a like-with-like comparison between countries and model while showing the implication of different definitions. It was a quite clear message that emerged from the meeting. So how the translation is done. You remember that figure, first slide? So essentially, what we did is we took the model's result called natural sink from a category of models is called the GVMs. We filter this result on the area of managed land by countries, and we sum up with the anthropogenic flux from the bookkeeping model. It's a very simple approach, but works quite well. Works well, you can see here in blue are the original carbon budget and IPCC estimates for land use as a source of about 4 gigatons of CO2. In orange, you see the original national inventory estimates, so I think about -3, a gap of 7 gigatons of CO2. With the translation is the dashed blue line. We are managed to reconstruct at the global level and also for most countries, the level, the magnitude and the trend. The translation, however, has very significant implication. First, it reduces the remaining carbon budget and anticipate the year of net zero. But even more importantly, reaching net zero CO2 globally would not be enough to halt global warming. There is a paper led by Miles Allen, I am part of that will come out in Nature next Monday. Stay tuned on that. And this paper revisits the original concept of net zero, which is the single most important simplification from climate science, policy relevant simplification. So if you reach net zero CO2 emission along with strong reduction in other greenhouse gas emission, then this is, from a physical point of view, a condition that should allow to stabilize temperature. But this definition has been developed originally in 2009, 15 years ago, by a group of scientists taking into account the global model's definition of anthropogenic sink. If you use the national inventory definition, then it would not be enough anymore to stabilize temperature. So stay tuned on this publication. And this implication, even once the models are translated, has to be communicated to countries in a wise way. So at the IPCC meeting, we discussed how we get there in terms of improving communication, improvement within each community, and strengthening collaboration across communities. So I'm going a bit fast here. From the national inventory community, it was remarked, the national inventory team says, well, we still continue to use the managed land proxy because it's the only widely applicable approach to estimate anthropogenic emission removal. It is a proxy, so it's far from perfect. It incorporates not only direct human-induced effects, but also some indirect human-induced effects, so notably CO2 fertilization, but this cannot be separated with a direct observation typically used by countries. The biennial transparency process mentioned in the introduction by Sean Hung is a great occasion to implement this proxy with a greater transparency. Remember that many developing countries still do not provide enough information on the area of managed land that they use. And pending availability of adequate resources, which is often a bottleneck for developing countries, additional information would facilitate understanding, including more detailed stratification of activity data on managed land, enhanced methodological information to help assessing the extent to which indirect effects are captured. We depend on the approach and the tier and so on. From the model's point of view, what has been discussed in ISPRA is encourage the model to provide operational translation of their result we're already there. And the global carbon budget, we'll hear later from Mike, we already have an operational translation for the historical period. And then we have a number of specific improvements for the global modeling and the Earth observation community. I'm not going into detail here. You will find all this information, more detail in the report. In terms of strengthening collaboration, there is a strong appetite to continue the dialogue. This should occur through regular dialogue supported by the IPCC task force on inventory, but probably the Global Carbon Project will also play a strong role. And it has been mentioned also the importance of data sets for comparing estimates. And one of these data sets is the so-called GRC LULUCF Data Hub. If you go on use the QR code, if it is big enough, you can access to this website where for each country in the world, you can find the data from 3 different data sets, and more data sets will come. One is the country official submission to UNFCCC on LULUCF. We included national communication, we annotated report, also RED, and we will include also BTR on LULUCF. Disaggregated by forest, deforestation, and other land use. Another data set is the Global Carbon Budget Community data set, both the original and the translated version. Another third data set is Global Forest Watch, using the Hansen data. And you can see here an example on the left, forest, and the right, deforestation. And you can see for each country, again, these are global level, but you can check for each country what these different data sets say. And first of all, you see that the original global carbon budget results are often for forests very far from the inventory. But once we apply this translation, then things in most cases match quite well. In other cases, you can see different levels of different trends, and should be seen not as a way to say you're right or wrong, but as a mutual learning exercise. You know that estimates of land use fluxes are very uncertain, and one of the things we want to do in the context of possibly the global carbon budget recap similar initiative is to sit down in the coming years around virtual table at regional and country level and say, okay, why our estimates diverge? And on the right, you see, for example, that the Earth observation community indicate that deforestation is increasing, has been increasing in the last 20 years, but both the global carbon budget and the national inventory, which are mostly based on statistics, say that deforestation is constant or slightly decreasing. We should understand, we should resolve this discrepancy for the next round of the IPCC and global stocktake. Oops. As I conclude, the meeting sows seed of cooperation. A dialogue has begun among communities that have never truly interacted before. If I have to indicate few keywords from the meeting, I would mention transparency from both community, but especially from the national inventory community, translation from the global carbon budget community, and global integrated assessment model, and communication of the implication. Then it was noted the importance of enhanced collaboration between the working groups of the IPCC and TFI in the 7th assessment cycle. It is absolutely crucial that the IPCC AR7 provide estimates and scenario for anthropogenic emission removal from land consistent with the national inventory definition. We should stop speaking different languages and live in different bubbles. This report will inform the scoping meeting and provide relevant information for the parties of the Paris Agreement. We hope that the first result of this dialogue will be seen in 3 or 4 years for the next round of the IPCC and the global stocktake. To conclude with a little bit of drama, so I'm sure that you will remember something from this side event. No, sorry. Let's go back. Okay. This was a real CNN news. In 1999, NASA lost Mars orbiter because of an issue of metrics. Okay. You remember that news? Yeah. Well, we should avoid that news in December 2028 with IPCC and UNFCCC orbiters that miss each other because of a different definition of anthropogenic sea. With that, I conclude this introductory part, and I would invite the panel to sit here and continue the discussion with them. And then we'll have room for questions. So, I would invite the panel that is composed by Kate Calvin, that is the co-chair of Working Group 3 of the IPCC Assessment Report 7. Mike O'Sullivan from the University of Exeter, that is part of the Global Carbon Budget, which is a key input to Working Group 1. Then I have Thelma Krug from Brazil, in the steering committee of GICOS, and previous vice chair of the APC in Area 6, and previous also chair of the TFI. Maria Sanz, member of the Task Force Bureau member from the Basque Institute of Climate Change, and Sandro Federici from the TSU of the Task Area Support Unit of TFI. So I would start with Mike. Yes. Or do you have, is there a microphone? Yes, yes. And then we can upload your slides. Yeah. So the question to you is, given the context that we heard, how the global carbon budget, what the global carbon budget is doing to support the dialogue in this field. Mike has some slides that are arriving. Okay. So the global carbon budget has been just published a few years ago. Again, if you Google global carbon budget 2004, you can find the paper and a number of, it's very transparent documentation of data. Please.
Great, yeah, thanks, Giacomo. Yes, good morning all. So, as Giacomo said, we published the global carbon budget 2 to 3 days ago. And this year we added a new kind of emphasis on this translation. So one of the new, so if you go to the next slide. Yeah, so this is a new figure we have this year, which is kind of outlining exactly what Giacomo said. So we produce the kind of land use change emissions from our definition, and then we actively translate them to kind of keep this dialogue going. So if you look on the top right, the orange line is what we call the ELOOK figure, so the emissions from land use change. So this is the active deforestation, reforestation. This is the net of everything, and that's about a source about 4 or 5 gigatons of CO2 per year. What we can do, as Giacomo said, is we can take the DGVM results, which is this kind of indirect CO2 fertilization effect, and we can add that on or subtract it. And that's when you get the kind of orange dash line, which is kind of this wiggly line. So not only do we improve that kind of translation, but we also capture intraannual variability, which is a key feature of the carbon cycle. So we can really see kind of short-term drought and ENSO cycles and how that impacts the carbon cycle. The black line is the greenhouse gas inventory. So as Giacomo already mentioned, we have a great match on a global scale. And then as another kind of line of evidence, we have the atmospheric conversion. So these are a completely independent set of tools which take atmospheric CO2 observations and then use atmospheric transport models to estimate where the carbon fluxes on the land and oceans are. And when we take the atmospheric conversion fluxes over the managed land, we get this kind of almost too good to be real match on the translation. So on a global scale, we really think we're capturing the kind of main dominating dynamics. The next 2 panels down are showing how we disaggregate through the different components. So the middle panel is the deforestation, mainly the deforestation fluxes. And for those fluxes, we don't really need a translation. The definitions match. So you can see that the solid red line is from the global carbon budget, and then the dashed red line is from the inventories. And there's no real translation needed there, and they match quite well. Where the translation's needed is on the bottom panel, where we have this kind of forest regrowth or forest category, which is where this large CO2 fertilization effect exists. And when we take the CO2 fertilization from the DGVMs, we then get this kind of nice match at a global scale. Next slide, please. So the global scale results look great, but when you start digging into the detail, we realize that we're not quite there yet. So there's a great paper by Clemens Schwing-Shackle. So Clemens is the one who's really leads this translation for the global carbon budget. And he broke down this translation to different regions. And if you look at the bottom of the green line or the top of the green line, depending which way the arrow is facing, that's kind of our translated flux. And in the black line or the black bars is the inventories. So you can see for each regions, sometimes we have a good match and sometimes we really don't have a good match. So although on the global scale, we think job done, when we look regionally, we realize that we're not actually there quite yet. And it's for a whole host of reasons. And we're still digging into the details on exactly why the mismatch exists. So for example, in Europe, we're not sure if some countries already account for this natural CO2 flux in their inventories or not. We don't fully know. Brazil, we've got different definitions of forest areas, and especially a big one is the CO2 fertilization effect. There's a real uncertainty in the models. We know it's there, but the magnitude is really uncertain. So that can cause discrepancies as well. And then China is an example where you can see that our translation gives quite a small carbon sink, whereas the inventory suggests a much larger sink. And we're thinking that this is because we're missing a lot of the afforestation in our models and issues with our cropland data. So I can go into more detail on the next slide. Yeah. So this is the result from last year. So this is showing the land use change emissions from China. So this is excluding all CO2 fertilization effects. This is just the direct effects from land use change. And you can see the blue model in the blue line has this large increase in land use change emissions over the last, say, decade. And the other two models don't. And I won't go into details too much, but our input data had issues, basically. And if you go to the next. So we realized that there was an issue with the FAO cropland data. And the paper came out a couple of years ago from a Chinese group where they looked at this FAO data and they realized, oh, there's issues with the cropland trends here. We've got a better data set. Why don't you come and use it? So we integrated that cropland data into our data this year, and we had a much improved. If you look at the last decade, we have now a much better agreement between our models, and we're indicating that China now is a sink of carbon due to this changes in cropland. We're still not quite there yet. We're still missing some afforestation signal, but it's much improved. So this is kind of a success story of how we can start integrating new data sets into our global carbon budget models, and we're getting better results. So next slide. Yeah, so this is my final slide. So in going forward, where we think as a community where the kind of best paths forward is to really integrate Earth's observations with our models. So there's a project which is just started now, funded by ESO, Recap 2, where we're doing just that. We're basically using as much high-resolution EO data as possible to really constrain the carbon cycles. Where our models really are fundamentally kind of not quite there yet is on disturbances and regrowth. And this is exactly what this project is going to focus on. So it's really going to look at how we can really constrain the disturbance and regrowth in our models to really align with the inventories. And then what also we've launched as well, a paper came out this year from PUK where we are really trying to get this near real-time carbon budgets going. So really look at these short-term fluctuations, because we know the inventories are kind of smooth and they're kind of like a long-term trends, whereas the carbon cycle is really dynamic and things can change rapidly with increased disturbances and things changing on a year-to-year basis. So we started a new initiative, the near real-time global carbon budget, to really capture these short-term trends. So this is kind of the future of where we're going. And one last thing is on the ESA Recap 2 project, we do have a close link with the inventory teams there. So we've got people to really help us translate or understand exactly what these inventory documents are. And that's really going to help us understand what's missing in them and what's missing in our models as well. So yeah, so there's a lot going on. So thank you.
Very good, Mike. So before proceeding further, I have a small question for you. Mike came in ISPRA, the IPCC meeting in Italy in July. And at the end of the meeting, he came to me saying, well, this meeting was an eye-opener for me. So why you said that?
So, okay, so there was the first kind of high-level IPCC meeting I'd been to. So from our point of view, I realized that the global carbon models and our community were very dynamic. I didn't think we were. And then once we got to that room, I realized the big structures and barriers in place. You've got this huge 100+ countries need to agree on every little thing. And from my perspective, I didn't really comprehend that. So it was how slow and how kind of hard things are to move from the inventory world, whereas actually we're really dynamic and we can change things year to year, month to month. And so that was the big difference, which I learned at that meeting, just how hard things are to change at the policy level.
Thank you. So we moved then to Kate. Kate here has a double role. On the one side is a key leading scientist on the integrated assessment model community. Integrated assessment model, IAM, are those set of models that provide estimates, emission pathway and scenario behind the IPCC, especially Working Group 3. So indicate is the navigation system that provide possible route to reach specific destination, like the well below 2 degrees. And she's also the co-chair of Working Group 3. So the questions are, for Kate, are, we heard that for the historical period, this translation is becoming operational with a number of publications and now in the global carbon budget, there are some publications, as you know, that we made on making the translation possible also for future scenario, which are the challenges that you see to make it possible. And if you see also possible that it become operational and can be included in the next Working Group 3 of the IPCC 7.
Yeah, thanks for that. And I think I'll start by saying that I am not actively working on integrated assessment models. In my role as IPCC co-chair, I represent all of mitigation, so not just that.
Yes.
And one big important thing is, as IPCC co-chair, we don't tell the science community what to do. So this is really up to the science community to take this on. And I would say some of the challenges around it are just, the data sets that we have. And also, as Giacomo noted, that both are correct. They're just different. And so I think that there is something that the scientific community has to think about, how to prioritize and what they're going to do resource-wise. But as IPCC, we don't tell them what to do. That is up to them. So when I'm thinking instead about IPCC and what might happen in AR7, I think it might be helpful to sort of talk a little bit about where we are in the process. So we are going to have a scoping meeting in about a month. And for us, what a scoping meeting does is it identifies which topics need to be covered and in which chapters. It's not a terms of reference, like you might see for other reports where you tell people how to cover something. We explicitly don't do that. We instead say, these are the things that we think are important, and this is how you might organize it. And then it's up to the authors to decide how to assess it based on the scientific literature. So from an IPCC perspective, what's really going to matter is what is in that scientific literature. If there are papers that do these sorts of comparisons, like Mike just showed, both with the past and the future, then that will work its way into the IPCC. But we really are dependent on the literature done by the scientific communities. And so that's probably the most important thing going forward, is to make sure there is a rich literature base that we can draw on, and that will influence how it is covered in the future.
Many thanks. I would then pass the floor to greenhouse gas emission expert Thelma, Maria, and Sandro. They were, of course, they attended the meeting. They were part of the steering committee, and the questions for them, I would like them to reflect, also complementing my recap of the meeting, was what could be the concrete steps. So we heard first from the models. There is a lot of ongoing activities from the modeling point of view. What could be the concrete steps that the national inventory community can do to enhance transparency, bearing in mind the issue of resources? That is a big issue. First question. Second question, how you see possible, which are the best strategy to continue the dialogue, continue investing in this dialogue with the global modeling community? And third question, feel free to select the question you feel more comfortable with. Third question would be, what I see most challenging is communicating the implications. So how to best communicate the implication for the remaining carbon budget and net zero year for countries, because it's a difficult piece of information to give. So, Thelma.
Okay. So let's start. Thank you very much, Giacomo. And it's a good opportunity for us to talk with the modeling community and the inventory compilers, I would say. So I do see that one of the main challenges that we have in terms of this big difference between the inventory and the modeling is the fact that every country has a lot of flexibility when they do their inventories. So they are the ones that define what managed land is And when you say about, what they should be doing in the inventory, they should be more clear. They should be more precise on how they are defining their managed land. So some countries say their entire country is managed. But if I take, for instance, Brazil, part of the natural forest is managed, is considered to be managed, despite the fact that there is this confusion that when you say managed, you are thinking that you are having hands-on, like with practices, which in fact that's not the definition of managed land that IPCC provides. So a managed land for Brazil in natural forests are lands that have been demarcated for the indigenous people, indigenous lands, protected areas. So these have been, recognized by the government under legislation. We do understand that it then should be considered as managed land. And a very large portion of our natural forests is not managed. Although when deforestation happens in these lands, they are automatically considered to be managed and reported as such. So the flexibility that the IPCC provides in the guidelines obviously creates problems for the modelers because they are looking more broadly and they are not considering that, for instance, countries have different tiers to report their emission factors. So tier one, just the four. Tier two is a little bit more refined, country specific. And tier three, when you could go through modeling, the land use fluxes, which is very difficult for countries to do. I think that only Canada and Australia, do that approach. So these nuances in terms of reporting in the inventories are not captured. Another difference in terms of definitions is their own definition of what, for instance, deforestation is. So some countries use thresholds below which they would consider the forest has been, deforested. In the case of Brazil, just to give some examples, it's clear cut, which has some advantages because you just go from forest to non-forest and you don't have to rely on height, canopy cover, or minimum area. You just say it went from forest to the ground. So all these nuances are not captured or are difficult to capture by the modelers. So this is one thing. Enhancing the definitions in the inventories would help very much, I think, the modeling community. Now, in another very small thing, Giacomo, I think that communication, as you say, is the key. For instance, we are going to have the report from the expert meeting, but who is going to read the report? So we are talking about, the modeling community. Maybe the inventory compilers will read those as well, but I have my doubts. So how do we make information accessible? And that is translating in a single page the protection implications that you have from doing this and that. In this environment, under the UNFCCC, I find that normally there is a huge resistance to change from the status quo. So saying, you have now to change from this to that, or vice versa, is absolutely complicated. And I see that because countries have their national systems for reporting. They have done a huge time series that is consistent, so that can see the trends. So I think that it will take some time for us to think about how to communicate. If it needs changes or not, I don't know. But understanding that these changes exist and potential implications on, in particular, the carbon budget, I think that is a must. So we have to improve our communication. And I think that IPCC has a huge task in front of it to communicate it as well.
Thank you.
You know that I never answer your questions, right? So, but
You're free.
I want to point out something before. I think I will call the Grassi issue the Grassi-Penman issue because
Yes, sure.
unfortunately Jim Penman is not here with us, but he was one of the first of this community that also was working on that. Having said that, I think, from the perspective of a compiler, which basically what is asked for is provide me data for putting the table measures where I can go in the direction that the IPCC is asking me to go. So I need data which are reliable in a sense that there are time series that are consistent, and that's why the IPCC guidance have all these principles. It's not the inventories are inflexible. I don't think so. Inventories are not inflexible. Inventories need methodological stability over time, but they can be improved. And the transparency framework will improve inventory substantially. In particular, because we didn't have data from developing countries, we will have consistent data from developing countries. There is much more knowledge today in order to apply the IPCC guidance faster than it was in the past. I mean, it took 20 years or more to develop countries to provide inventories, which are what we have seen today. So I think we are in a point where inventories are becoming the keystone of how we are going to change the future in the land use sector. Models, and I want to be very clear on that, models as they are used in IPCC do not provide statistical uncertainty, which is what inventories do. Models provide ranges. And this is what the bookkeeping models are being doing as well. And this is the exercise that you were talking about, that they are getting a range which is much more smaller. They are getting more consistent. So I think what we are asking for, and I think what we are agreeing on, is let's bring an order run into this range, which represents what inventories or how inventories are seen definitions. And I agree with Thelma, the problem is not for models in terms of what Jim Ski was saying is a matter of approaches. Well, it's a matter that models need standard definitions globally. And inventories are not providing standard definitions because your definition depends on how you're going to manage your resources. And that's something that is not easy to be resolved. You can be more granular in the future, and probably models can be rethink a little bit more in order to represent better the reality on how the human influence is given into ecosystems. But one thing that really worries me more is that we are being very worried about the fact that there is this CO2 fertilization. I see two things. First thing, why China is showing this big signal? Because the large afforestation in China is young trees. So they are responding probably with higher growth rates, right? Another thing I am really worried about is that this signal that climate change is providing as a fertilization is probably saturated and even will be reverted, in particular in adult forests. So we also have to think on those things when we are putting this question in the table for the IPCC and for the countries themselves. And yeah, well, let's see though. I'm fine, No, I'm more worried about, how this can be actually reverted. And one fundamental issue here is when I do a perturbation on a biological system, I'm sorry, I don't really care anymore about if I can separate or not the anthropogenic from the non-anthropogenic. The system is reacting to the perturbation. And I need to take this into account when I will try to manage this system. So I think we are in a good track. I think it's wonderful that we had a conversation between the different communities. I think it was very good that we also brought in the Earth observation community, because this can be also, one community that can help to, for example, provide much better data for both communities to work with and to improve activity data in the case of inventories, but also input data in the case of models. So, I mean, I believe we are going in the right direction, but I believe we also have to take into account some other things, like, for example, what Thelma says, the fact that we can reverse this signal and we don't know what to expect, because we have been assuming in models that the CO2 fertilization in all cases, age structure classes is the same, and I don't think so. There are papers that saying that the CO2 fertilization signal in mature forests is much less or even none. And the models are assuming the same signal for all type of forests, mature, young forests. And I was very pleased to see the China signal, because that confirms probably this sense that where you have large afforestation, young plantations, the signal to CO2 fertilization probably is higher. So all these things are also need to come into the conversation. But bringing the CO2 inventory compilers into this conversation, I think is a great opportunity to link also the actual managers into how you will in working group 3 to design the pathways for the future. Because one of the things that I'm not anymore an inventory compiler, but I'm working with managers now to see what you can do to increase your sink, or what you can do to minimize the impact of or the perturbations of the climate change.
Thank you, Maria.
Yeah, I will be short by building on Maria's answer. The goal of a greenhouse gas inventory is to inform a policymaker on which actions to put in place in the forest land, and now we're speaking about forest, for mitigation. That is the goal. The inventories are there to inform about the status of emissions and then the options and the result of mitigation action. And there are two fundamental qualities. One is the symmetry. You need to treat gain and losses, so CO2 emissions and CO2 removal, symmetrically. If you don't do that, when you go for accounting, you bias your accounting and you fail in guiding your policies where you want. And the second is the liability. The country takes the liability of what is doing in a managed land. And this liability should be full, because if it's not full, again, you bias the result of the policies, and then you don't get where you want to go. So these are fundamental constraints that are needed, are important. The second comment is about the CO2 fertilization, following Maria. Now, science, simplification are very important for science because they help in progressing. However, there are two considerations here. The first is that, is the CO2 fertilization actually the predominant driver? I mean, if it doesn't rain, you don't have an additional growth because of CO2 fertilization. FAO is working on a paper on the analysis of the last 20 years of forest inventory data that will likely show that the increment of forest is decreasing. It's decreasing because of global warming. I mean, the CO2 fertilization is increasing in theory because CO2 keep accumulating. Nevertheless, the forest increment in the boreal forest, according with the forest inventory data, the increment, the impact on increment is decreasing because of temperature. Is the temperature increase the main driver? And then dialogue with the modelers. Please, you shall consider two elements here. On the other side, you need to look better to the emissions. You are excluding forest fires. Forest fires are an important component of the forest budget. If you exclude the forest fire and the following regrow, you build a picture of forest which is fictional. It's not a real forest. And this is a big problem, because if you go for a fictional budget of forest, how you verify it? Maria said there are no uncertainty. Of course, you don't know. I mean, it's not the real world. It's another world. If there is not the real world, how the community may verify that countries are actually reporting what is happening? If you go for fictional reality, is not verifiable. And this is a big problem, liability and so on. And the second, in the harvest, Faustat data, of course, is the best data set available, but the Faustat data are a subset of the actual harvest. A country like Germany, which is one of the most precise countries, we are in Japan, is the most precise country in the world. But I guess if you do a survey, Germany is named the second. They found a 20% discrepancy between a stock difference and the gain and loss, because a fraction of harvest, of course, is not catched. It's not catched because you have informal harvest. It's not catched because any company does not declare the total wood harvested, because they pay taxes on that. So if they may cut at 20%, is their welcome. There is also illegal harvest. And this is important because, again, you have this symmetry between harvest and subsequent regrowth. If you bias one side, you bias also the other.
Thank you, Sandro. So, yes.
Can I just compliment a little bit? The issue of CO2 fertilization is something that we do need to take attention. Maybe there is, I don't know if full knowledge of what we mean by this, right? So there was a time here in this UNFCCC when there was an invitation to the IPCC to please factor out from the changes in carbon stock the natural effects and indirect effects from CO2 fertilization, nitrogen deposition, from the direct anthropogenic effects on the changes in carbon
It was
stock.
2001, if I remember well.
Yes, and
A long time
well,
ago.
and this is why IPCC responded and said we cannot do that. We cannot separate the natural and the indirect from direct, right? So managed land concept was created. And when it was created, then you are appropriating of the so-called CO2 fertilization, which Sandro well says, it is changing. But let me just say of the implication of that in the reporting. So we don't really know for many countries how much is that CO2 fertilization for the different types of forests. Well, we don't even know if we consider a single forest. Giving an example, it is ranging now from Brazil for the managed land, 0.48 tons of CO2 per hectare per year. Now, if you go to another country in the BTR, it is 2.34 tons of CO2 per hectare per year. So what is the implication of that? You are creating a huge sink. So when you're using your net, then it is, in compensation with the other sectors, that is going to become a huge issue. And so I think that that attention has to be taken.
Yes.
So it's just to highlight this. We are talking about CO2 fertilization, but I don't know if we were clear about the, to all participants on that effect.
Thank you for this clarification. I would then, before opening the floor for questions, we still have 10 minutes, a quick reaction from Mike on the CO2 fertilization and fires. Sandra mentioned that fires are not considered by models. I mean, they are considered, but the issue is, do you consider anthropogenic or natural? And then CO2 fertilization. During the APC expert meeting, actually, the National Inventory team challenged several times the model and say, but are you sure that CO2 fertilization is so important as your model says? So you want to react?
Yeah, so there were 3 points there. The one first one I remember is the harvest. We're constrained by the data we use, as you say, and we're happy to change the data at any point. So if there's any better data out there, we're happy to integrate it all the time. Second point on fires, we do include fires. So the DGVMs are fire enabled, most of them, and they fires in. The ELUC models, the Bookkeeping models, when we have a land use change from fire, that's included. So fires are included. Our fires might not be accurate or fully accurate, but the fires are there. And we've got new initiatives now with ESA where we're constraining our DGVMs with satellite-derived fire. So we are kind of, the models are fire enabled, and we have steps in place to improve the representation of fire disturbances. So I feel like we are addressing this issue.
So the question, sorry, if the question is, to what extent you consider anthropogenic, to what extent you consider natural, I think.
I think this is really difficult to answer because, for one, from satellites, you can't determine what's anthropogenic and what's not. So it's really difficult. I mean, in a lot of regions, all the fires are anthropogenic, right? And then there's a climate effect from a spillover. If you burn your forest for a pasture, and there's a spillover into the natural land, and that's a degraded fire. So there is this definitional issue, which this is something we're working on now, and we've got projects coming forward where we're looking at this split exactly, and we're looking at methods to really separate the two. So this is something that we are very aware of and we're working on. Regarding CO2 fertilization, I feel like the magnitude, yes, maybe we're not exactly sure on the magnitude of CO2 fertilization, but we know it exists, right? It's definitely there. Otherwise, there would be no discrepancy between the two. That is the indirect effect. Yeah, okay, and there's loads of evidence. So we've got leaf level evidence in labs that CO2 fertilization exists. We've got eddy covariance towers where we can look at the CO2 fertilization. We've got plots in the Amazon and looking at old growth forests, which are growing over time. So these aren't disturbed. These are just forests responding to environmental changes, and they're growing. How do we explain why they're growing? It's CO2 fertilization. So and in our models, we do have species discrepancy between the CO2 fertilization effect and younger trees would grow faster than CO2. So I feel like it's a disservice to kind of discredit the models like that. We've got a lot to work on, I do admit, and the CO2 visualization is one of the major things to work on, but these processes and mechanisms are there, so I wouldn't just dismiss the models outright.
Okay, I would open the floor for questions, including any from online. I already see Stephen wants to, Stephen, then yes. Please introduce your name.
Stephen Sitch, University of Exeter. Can I make a comment actually on the CO2 fertilization effect? I think when you look at the global carbon budget, 50% of the emissions, anthropogenic emissions, go into the land and the ocean sinks, and you need a mechanism for that. So if it's called CO2 fertilization or something else, you need a positive mechanism to bring CO2 into the natural ecosystems. There are not many mature face experiments. So David's here, he's doing the one in Brazil starting up now, but in the one in the UK, it looks like there is a sink in the mature forest in the UK. And as Mike has already sort of alluded to, you know, you put a leaf into a cuvette, you raise CO2. We all know that the photosynthesis increases, we see CO2 to a level. And the question for the models is how the productivity, photosynthesis, then gets translated into growth, recovery, and all these sorts of things, which is a weakness in the models we can improve.
Thanks. On the same topic, you can introduce yourself.
Yeah. Davi Lapola from the University of Campinas, Brazil. Just to highlight, thanks, Stephen, that we are starting next year the first phase experiment, free air CO2 enrichment experiment ever done in a tropical forest. And tropical forest, I think everyone agrees, is a big sink, considerable sink. And just seconding Stephen as well, there are the few phase experiments in mature forests. They are recent. For example, the one in temperate forests in the UK, and the initial papers showing that the initial response is positive. It's not saturating, at least that's the evidence we have now. But let's wait what we see in tropical forests next year onwards.
Thank you. Okay.
Thank you very much for the event. And my question is more general about the implications. So the policy.
Can you introduce?
I'm sorry, Ferdinando Cotumia from Domani, Italy. So my question is about the implication for policy. So do we need, we do have a shorter carbon budget. So do we need to anticipate net zero? This is the message of what we are seeing here.
So I could start, but then feel free to complement. So even the paper that will come out next Monday, make it clear that if you apply the national inventory definition for reaching the Paris Agreement target, there is no really alternative for countries. Then from a physical point of view, the net zero CO2 would not be enough to halt anthropogenic global warming. So the message would be, this doesn't mean that the mitigation effort should be necessarily revisited, but continue your work toward net zero and don't stop at net zero, essentially. Don't stop at net zero. Go beyond. From a physical point of view, use the national inventory definition of anthropogenic sink means that we have to become net negative.
Just to clarify on that, I think what you have to do is look at like with like. So when the IPCC is talking about net zero years, they are using the modeling approaches that Mike talked about. And as long as you're sticking with that as your measurement, then those numbers are related to that. If you're going to look at inventories, you would need to look at the inventory relevant years. Both are correct and both would get you to the same point, but they're different. So you just have to, match like with like.
May I respond to the policy implication? Obviously, if a country sees that it has a huge sink from the appropriation of the CO2 fertilization, so you're doing nothing, it's mature forests, it's natural forests. Well, maybe we have to think what we're going to do with this big sink. So you may be thinking of trading this thing, or Article 6 is there. So it is highly complicated to think of the implications, but there are or can be profound implications from the way we are estimating this big sink that are coming from possibly indirect effects of, Sandro.
Yeah, not to respond to Mike. Yes, when I was speaking about fires, I was referring to bookkeeping models, not to the entire framework. Of course, yeah. So, what is anthropogenic? About the CO2 fertilization, in 1992, I was in Italy. We built 2 chambers in the real forest, Mediterranean forest. In one chamber, we doubled the CO2, so we were pumping CO2, 700 ppm, and the other was at 350. Because unfortunately, years have passed, and now we are at 420, but at the time, double CO2 was 700. Now double CO2 is 850, 860 also soon. So we found, I was measuring with my LiDAR the photosynthesis in the leaves. The leaves were having a much better, a much better carbon balance. They were absorbing more CO2, but the 2 chambers at the end, the budget was the same because the chamber with double CO2 was losing half of the leaves because it was a Mediterranean environment, you don't have water. So the plant was taking the advantage of a better carbon budget for the single leaf to save water. So
I would take one
the
last
CO2 effect is to be seen.
Your last question, and then we close. We continue informally. Yeah.
Yeah. Thanks, Giacomo. Paul Zakor from Carbon Counts. I just wanted to add a third pillar into this, and I think you've all touched upon it, and Thelma touched on it a few times. Is if you start putting parcels of activities into tradable units, we're going to have another problem there because you're going to be able to go back and ex post adjust those when they've been accounted and everything else. So I think you need to think really about not just the discrepancies between the models and the inventories, but also how you're going to deal with the accounting later on and what the implications could be, because I think that's a bigger or as big a policy implication there. And especially when you're allowing claims against those credits. So you're allowing, you're basically locking in that accounting system on the date of issuance of that credit. So
I think this is an important point. So we referred so far to the discrepancy between global models and country reporting. So as a matter of fact, the vast majority of countries base their accounting toward the targets entirely on reporting. Not all. Some countries still use KP accounting rules. That has been an effort done in the context of other countries. But the vast majority of the world country, if you see in the INDC, a long-term strategy, a net zero target, they count the full landscape, which is exactly what we discussed today. A different approach may occur in Article 6. Article 6.4, we just heard that methodology have been approved, refer to durable and deliberate removals. So deliberate is something different from the managed land proxy. My humble understanding is that Article 6.4 is a sort of follow-up of CDM, where indeed CDM, they didn't have forest management. CDM has only afforestation, because proving the additionality, the deliberate action on forest management activity is extremely challenging because of the region we indicated today, because you cannot really distinguish with direct observation what is direct human induced and what is a natural feedback, indirect human induced. So the different approaches may be possible at accounting at country level and accounting at project level for credits. Yes, I like they give me that we have to stop. So I would close it here. There is a lot of interest. Thank you for attending and follow up the issue. But I'm curious to see what you wanted to say.
Yeah.
Nice to meet you.
I know it's an ongoing conversation.
Sì.
Not easy job.
No.
There's so much uncertainty.
Very
Hi.
So what is it?
Yes. Excellent session. Thank you for bringing up the fires.
Sir?
Thank you for bringing up the fires.
Yeah.
Yeah.
Right,
This is the next thing we're going to